and welcome back, everyone. I'm really excited about today's class because we are going to be talking about how to solve for the indicated variable. Now, what I mean by that is we'll be given an equation that has a ton of different variables in there, and we have to come up with a strategy to figure out how to isolate just the one. I like this section a lot because students always tend to come in with this, this preconceived notion or experience, and not really preconceived, but you know what I mean, or past experience that kind of makes them fearful of this particular topic. So I'm hoping that with us working together and the way I'm breaking it down, I'm really, really hopeful that it makes sense to you all. As always, please, if you have any questions, how'd you get that? Where did that come from? How are you allowed to do that? Ask that in the chat and I will answer your questions. On that note, let's take a look and dissect this particular topic, which I love so very much. Okay, we are going to solve for a variable in a formula. First things first, remember to follow the rules for solving linear equations. Those rules do not go away. Remember that you can move an entire term only by either adding or subtracting from one side to the other. As a quick reminder, you have to use the opposite operation to move a term or part of a term to the opposite side of the equals. If you're going to move an entire term, you have to either add it or subtract it, whichever is opposite. If you end up choosing to multiply or divide by a quantity, you have to do that to every single term in the equation. It doesn't matter how many terms you have. If you're going to multiply by 3, you've got to multiply every term by 3. If you're going to divide by 5, you got to divide every term by 5. That's just the rule, okay? And remember, we're taking steps to get the term that we want by itself alone, right? We have to move all the other terms away, and then if that term has a coefficient, and at the very end, that's when we divide to separate that part of the term. Okay, let's look. My first piece of advice to you all regarding these problems is that sometimes reading the problem aloud or hearing the problem, loudly in your mind can help you to hear the operations being used in the problem. Or in other words, it will help you to recognize what those operations are if you're really taking a moment to think about, what do I see here? Then you want to focus on performing the opposite operations to isolate the indicated variable. If you hear addition, the opposite is subtraction. If you hear multiplication, the opposite is division. So you want to think about those things as you progress through the problem. My second piece of advice is that sometimes when you read the problem aloud, the very last thing you say is sometimes where you'll begin, right? You'll essentially work backwards to isolate the variable. It doesn't always work every time because, again, it depends on how the equation is structured. But more often than not, it might be a pretty handy maneuver to try out. So let me show you what I mean by that. For problem number 1, we have A is equal to 3 times P minus 4 times Q. A bunch of things are happening here. First thing, we have 1, 2, 3 terms. The second thing we notice is that when I read this aloud, you heard times, so multiplication, which means eventually we'll have to divide. And you also heard minus, which means the opposite operation is going to be addition. So here's how we do this. And I'm going to show you a perspective. You can totally adapt and make it your own. But follow along, see what you think. So I want to solve for P. And I know that P is in this term. So I'm actually going to do a quick little circle around 3P. And for me, it says, okay, I need this term 3P by itself. So that way I can eventually get P alone. Again, when I read this out loud, I read A is equal to 3 times P minus 4 times Q, or minus the term for Q. So what we're going to do is we're going to work backwards. The last thing I said was minus 4Q, so I want to move that entire term. You can only add or subtract terms to move them from one side of the equation to the other. Notice what I have here. Now, these are definitely not like terms. Recall that like terms have to have the same variable to the same power. Well, one's an A and the other term's a 4Q. That's okay. So what I'm going to do is I'm essentially going to write exactly what I see. And remember, we're going to read from left to right or top to bottom. So this says A plus 4Q. And that's exactly what I'm going to write. A plus 4Q. Here's the left-hand side of the equation. We definitely drop down the equal sign, and then we're going to bring down my 3p. Notice that by moving that negative 4q, by adding it to both sides, I've now isolated the term 3p. At this point, we know that 3 is connected to p by multiplication. This says 3 times p, so we're going to divide. What I'd like you all to get into the habit of doing is writing your answer in one of two ways. Here's the first way. If I divide by 3, remember the rule. You have to divide every term you see by the same quantity. So our answer in this case is going to be a over 3, which is also 1/3 a, which, you know what, I'm going to write 1/3 a because I want you to get used to that. So this becomes 1/3 a, and if you're wondering where that 1 came from, remember, what is the coefficient of this a right here? It's a 1. You can write in a 1 in your notes, totally up to you. You get to decide and go ahead and make that decision. I'm going to leave it out. I'm just going to write 1/3 a. Plus, this becomes 4/3 q, right? So your coefficient is 4/3, then you have your q, is equal to, and then 3 divided by 3, well, that's just a 1, so it's 1p, which is just p. And we have successfully isolated our p. Another way to write our answer, if we wanted to, I'm going to write or, is we can say that if we're dividing all terms by 3, we could combine these into one fraction. You could write a plus 4q all over 3 is equal to p. The only downfall with writing our expression this way, which is acceptable by the way, the only downfall with writing it this way is I have found students forget the fact that what this means is that the term a is being divided by 3 and the term 4q is being divided by 3. Oftentimes when students see it as one fraction, they think one or the other, and that's not the case. Both terms are being divided by 3. So I would accept either answer. Okay, let's try it again. Let's take a look at number 2. So for number 2, we have j equals k minus m divided by n. Hopefully, as I read those operations aloud, you would say, oh, minus, so I definitely have to add, divide, so I definitely have to multiply. Now, if I read this aloud again, j is equal to k minus m divided by n, the last operation you hear is divided by n. And guess what? That's actually where we're going to start. So because this is such a tiny, tiny font, I'm going to rewrite this because why not? So j is equal to k minus m divided by n, and I'm going to circle this m. Just keep in mind that the negative belongs to the m. But my focus is, how do I get m by itself? So again, the last thing we said was divided by n, and then we recognize we have 2 terms. In this equation, we only have 2 terms because my fraction represents 1 term. Okay? So I am now going to do the opposite of divided by n, and I'm going to multiply by n. What you do to one term, you do to the other term, right? Because we only have 2. If we had 3 terms, we would multiply by n to all 3 terms. You get my drift. So notice what we have here, n times j, which we can simply write as nj. You can put the times in between, but typically we don't do that, so you can write nj. You can also write jn. Remember, multiplication is commutative, so the order does not matter. N times j is the same as j times n. Then we have our equals, and then notice that n is in my numerator and n is in the denominator, so these divide each other out. So n divided into n is 1, and that leaves us with k minus m. Awesome. We eliminated the fraction by using a strategy that we've used earlier in this unit, multiplying by the LCD. Kind of cool, right? None of these topics go away. We get to still play around with them. So again, my focus is to get m by itself. So if it helps, I'm going to circle m and say, okay, I'm still thinking about you. I'm still thinking about you. I want you by yourself. But what we have here is that we have the term k attached to the term negative m, which is a problem. So that means we want to get rid of k. We want k to move to the other side of the equals. Oh, you want k to move to the opposite side? Well, notice here that we have a positive k. So that means we have to subtract k. That is the opposite operation. What you do to one side, do to the other. Okay. Again, we are going to read this. Don't overcomplicate it. Don't overthink it. Just simply read what you have on the paper. Notice I have nj minus k. All right. nj minus k. That looks great. That looks exactly like what I have here. Bring the equal sign down. K minus k leaves us with a 0, but 0 minus m is still negative m. Hopefully all of this makes sense as we take each of these little steps towards isolating the indicated variable. Now we're actually almost done. Notice it says solve this for m, not negative m. So that's a problem. There are a couple things we can do here. The first thing we could do is we could recognize that the coefficient of my m term is actually a negative 1. So I could divide each term by a negative 1, and I'll show you what that looks like. But then I want to talk to you about thinking about what happens when you multiply or divide by a negative 1. So let me show you. I want to isolate m, so that's a negative 1, so I'm going to divide by negative 1 here. Every single term gets divided by negative 1. Now let's write out what this becomes. A positive nj divided by a negative 1 is a negative nj. Remember, it's not negative n negative j because nj is one term. So it goes from positive to simply negative. A negative k divided by a negative 1, well, that becomes a positive k. And finally, a negative m divided by a negative 1 is a positive m. And there you have your final answer. What I want you to notice is something very interesting. And then let me see if I can cover this up without blocking the two equations. Yes, that's so good. So notice what we had. We had nj minus k equals negative m. When we multiply or divide by a negative 1, all that happens is all of the terms, their signs flip. Right? Because a negative times a positive, well, that becomes a negative. A negative times a negative, well, that becomes a positive. So all of the signs are simply going to switch. Take a look. Because we wanted to divide by the negative 1, which, by the way, is the same as multiplying every single term by the negative 1, we went from positive nj to negative nj. We went from negative k to positive k. We went from negative m to positive m. Kind of a neat trick, right? It's a great way of thinking about what is the impact of multiplying or dividing by a negative 1. Okay? Hopefully that is helpful. So your final answer is here. Negative nj plus k is equal to m. We have successfully isolated m, so we did our job. Let's look at number 3, which is more complicated. Okay? Excellent, Doc. That's hilarious. So we have, now this one's tricky. So pay attention to how I'm reading this out loud, and then I want you to kind of think about the steps I'm going to take. Okay. H is equal to 1/6 times W times V minus R. All right, there's a lot going here. I'm going to read it slightly differently. H is equal to 1 divided by 6 times W times V minus R. That's kind of interesting, isn't it? So one of the things that I like to do, and this is something that I've been emphasizing throughout this unit so far, is I like to cancel denominators whenever possible. So the one thing that tends to trip people up is that I'm allowed to do what I'm about to do right now. So I'm going to rewrite this. The next thing I want you to recognize is we have only two terms. Our first term is h, and our second term is 1/6w times v minus r. This whole thing is one whole term. No worries, Kayla. Thank you for joining us. Because this is one whole term and this is one whole term, so I have two terms, I'm going to say to myself, I want to get rid of that fraction. I don't want to have a 1/6 there. So to eliminate this, I'm going to multiply by the LCD, just like we have all the other times before, whenever we had fractions. So I'm going to package each term in parentheses, and I'm going to multiply by the LCD. Notice our only denominator is 6. So I'm going to multiply by 6, and I'm going to multiply by 6. So on this side, I have 6 times h, which is simply 6h. And notice that because this is one term, and I'm multiplying by 6, I can say, oh, well, 6 is in the numerator, 6 is in the denominator. These are going to cancel each other out, leaving us with 1s. And then we have 1 times w is simply w times v minus r. Not bad, right? Just like that, we've gotten rid of that fraction. Again, you're going to use a strategy whenever you have fractions in your equations, but you have to be careful with how many terms do you have, and that's how many times you multiply by that common denominator. All right, moving forward, we have 6h is equal to w times v minus r. Well, w is connected to v minus r, and I want to solve for r, so I'm going to circle this carefully. And hopefully you all agree that r is inside the set of parentheses. And the only reason that set of parentheses is there is because of this w. Some of you might say, well, why don't we distribute the w? You can. You can. And what I'll do on a separate sheet of paper is I'll show you other strategies for this particular problem. And we'll get the same answer, I promise. But instead of distributing, because remember the goal is do the opposite operation. Do the opposite operation. Thank you, Liam, for joining us. Good to see you. So because we want to focus on doing the opposite operation, we wouldn't distribute, although you can. So instead of distributing w, because w times, we want to do the opposite operation. So w times, oh, that just means we're going to divide by w. So what I'm left with here is 6h over w is equal to, and then we notice that we have a w in the numerator, a w in the denominator, so we're allowed to reduce. We're going to divide each by w, and that leaves us with 1. Because we have a 1 in front of this parentheses, we actually don't need the set of parentheses anymore. 1 times v minus r is simply v minus r. I'm going to use the same strategy. Let's circle r as a reminder. That's what we want to solve for. Notice that I have two terms on this side. I have a v and I have a negative r. Well, that v's got to go. Do you all see that this is a positive v? So in order to move that positive v, we're going to subtract it. And what you do to the right side of the equation, you do to the left. Here's another part where I've seen students say, whoa, how do we write that? What does that actually become? Well, don't overthink it. Notice what you see here. I'm going to read it out loud. 6h over w minus v. Okay, 6h over w minus v. That's how you would write it. You do not bring v to the denominator because that's not what you divided by. You didn't divide by w minus v. You only divided by w. Then you subtracted v. So you have to be very intentional with how you write your expressions. Don't jumble them up if that's not what happened. So we have 6h over w minus v is equal to what's left, which is negative r. And if we use the same strategy and the same idea that we used for number 2, then all we have to do is recognize that in order to go from a negative r to a positive r, we actually have to flip all the signs. So we have 1 term, 2 terms, 3 terms. If we divide or multiply every term by a negative 1, so I'm going to make a note here, multiply or divide every term by a negative 1 becomes then flip all the signs. Your first term is 6h over w. It was positive, make it negative. Your second term was a minus v, so it becomes positive v. Your third term was a negative r, well now that becomes a positive r. And we have successfully isolated the indicated variable. Hopefully that's not too bad so far. I'm hopeful that you're all comprehending the path that we're taking, and that's because of what it is that we're seeing. Remember, the goal here is, because we're isolating the indicated variable, we always want to use the opposite operations. So if you know you're multiplying, then try to divide. If you know you're adding, then try to subtract. So be very careful about the way in which you progress through these problems. And again, say it out loud, especially if you're at home. I mean, people might look at you like you're crazy, but that's okay. Crazy is good, right? Sometimes, maybe. Read it out loud, try to digest what it is that you're seeing, and then move through the problem. Let's take a look at some more examples. Number 4, we have f is equal to 2 divided by 3 times pi times j. Okay, I like it. So, Doc, you asked a really good question. Because of the location of the variable we are trying to solve for happens to be on the right-hand side, that's why we're moving everything away from the right-hand side. But I could easily rewrite this equation. I could easily say, oh, that's the same as 2/3 pi j is equal to f, right? We still have to isolate j. And just for you, Doc, I'm actually going to work on this equation. Even though, like I said, they're exactly identical, but I want to show you that it doesn't really matter which side you're working from, so long as your goal is to isolate the indicated variable. The j in this equation happens to be on the left, so we want j alone. All right? So let's take a look. So we have 2 divided by 3 times pi times j is equal to f. One of the first things we can do, if you'd like, is notice we have a fraction here. So here's my first term, here's my second term. You're welcome, Doc. So because we have because we have 2 terms here and we are dividing by 3, let's do the opposite by multiplying by 3. Okay? When we multiply by 3 on both sides, notice numerator, denominator, 3 into 3 is 1. That leaves us with 1 times 2 times pi times j. Okay, that sounds cool. And then we have f times 3. Please don't write f3. That's just weird. Okay, that's just super weird. You want to write it coefficient variable. So this should be 3f. We just fixed the order. Coefficient variable. Okay, I'm going to circle j again, because I want to get j by itself. Now, the really cool thing about this, everyone, is that these are all connected by multiplication. 2 times pi times j, right? Well, the opposite of times is divide. And if I want j alone, why not just divide by 2 times pi? Do that to both sides. 2 divides into 2 once, Pi divides into pi once, and voila, you're left with j is equal to 3f over 2 pi. And that's your final answer. Not bad, right? Your turn. I would like you to do number 5. I'm going to read number 5 aloud to you and give this a shot. We have c is equal to 1 divided by 4 times k times r plus p. Go ahead and isolate p. Welcome, Ashanti. Everyone, give this a shot. Type in your answer into the chat. Good luck. This looks fantastic. I'm seeing lots of answers in our live chat. So let's take a look. Notice here, because we have a fraction and we also recognize that we have 2 terms in the entire equation, we're going to start by multiplying by that LCD. Thanks, Doc. So we're going to start by multiplying both sides by a 4. That leaves us with 4 times c, which is 4c. Notice here these 4's are going to cancel each other out. They divide out, leaving you with a 1. So 1 times k is simply k. Then we have k times r plus p. As a reminder, we're trying to isolate p. So again, instead of distributing the k, because it says k times r plus p, we want to do the opposite. So we're going to divide both sides by k. Notice here we have 4c, I'm just going to bring this over. We have 4c over k is equal to, notice our k's are going to divide each other out, leaving us with 1's. And 1 times r plus p is simply r plus p. At this point, I want to focus again on getting p alone, and that means I've got to get rid of r. We have a positive r here, so we're going to subtract r from both sides. All we're going to do is rewrite what we see here in the order in which we performed our operations. So we have 4c divided by k, then minus r. These are opposites, they cancel, leaving you with a 0, but 0 plus p is simply p, and there is your final answer. So for all of you who put into the chat, p is equal to 4c over k minus r, excellent, excellent work. That is fantastic. Go ahead and try number 6 and 7. 6, we have mx plus by equals q for y. And then number 7 is p is equal to 3n minus rt plus x. And this time you're solving for t. Let's see what you get. Good luck. So after reviewing lots of answers in the chat, I'm excited to show you exactly how this breaks down. So first things first, let's take a look at number 6 and recognize how many terms we have. So we have mx, which is our first term, a positive by, which is our second term, and a q, which is our third term. Now keep in mind, we want to focus on getting y by itself, which means this term has to be alone. So when we focus, well, I can't talk anymore. When we focus on isolating the term itself, recognize that mx, that term, is on the same side as by. So we want to get rid of the term mx. Remember, the only way we can move terms is by either adding or subtracting them. Since this is a positive mx, we're actually going to begin by subtracting mx. What you do to the left side of the equation, you do to the right. Notice mx take away mx. Those terms cancel each other out, leaving you with 0. But 0 plus by is still by. Next, we have q minus mx. So we're going to write exactly that. At this point, we want to isolate our y again. And when you think about isolating the y, you have to say, well, y is currently attached to b. They're connected by multiplication. This says b times y. So if that's the case, I'm going to have to divide. So in the chat, I saw multiple answers, but most of them looked like this. So we divide by b, and we divide by b. Notice here b divided by 3, well, b divided by b is 1. These cancel, leaving you with 1. So we have y is equal to, and I am okay with you writing your answer as q minus mx all over b. That totally works. For those of you who wanted to divide each term individually, just like we looked at on the previous page for number 1. So if we wanted to rewrite this, so I could say, or you can write your answer as y is equal to q over b, right? The first term is being divided by b, and the second term, negative mx, is also being divided by b. All right? And Claire, that's okay. It just takes practice. Keep in mind, Claire, that when we're moving terms, you can only either add or subtract them. You don't want to divide because it does something totally different. Okay? I'm a little bit nervous to show you guys because I don't want you to make that error. But you know what? I'm going to do it anyways. I'm going to show you what it looks like if you divided instead of subtracted. So let's rewrite mx plus by is equal to q. If I accidentally said, well, I'm going to divide by mx because they're being multiplied together, keep in mind what that means. If these two are being multiplied together, m times x, then you either divide by the m or you divide by the x, right? That's how you separate these terms. But let's say that you were like, no, let's just divide by mx. That means you have to divide every term by mx. Do you see what's happening right now? mx divided by mx is actually 1. So that's 1 plus by over mx is equal to q over mx. And what ended up happening is that we just totally overcomplicated where y was. So we're essentially packing that term with more variables when we want to do the opposite. We want to isolate the y. So be very careful with how you're progressing through the problem and notice what you're actually doing and how it influences the problem itself. Excellent. Thank you, Claire, for sharing that with us so that I can show you all what that looks like. For number 7, we have p is equal to 3n minus rt plus x. Again, we're trying to solve for t. So I'm going to put a tiny little circle around that and hopefully not block any of the other information. Notice we have 1, 2, 3, 4 terms. On the side where our term is with a t, we have 3 terms altogether, which means 2 of those 3 have got to go. So notice I'm going to start with the 3n. We can move the entire 3n term by using the opposite operation. It was a positive 3n, so let's subtract 3n. Bring it over. I'm going to do this in baby steps just so you can see the progression. So now I have p minus 3n is equal to, notice 3n minus 3n leaves us with a 0, but 0 minus rt plus x is still negative rt plus x. Okay? Again, we want to focus on isolating the term with t, which means the term that does not have a t, again, has got to go. So we have plus x here, which means we're going to subtract x. So let's bring that over to the left side of the equation. I now have p minus 3n minus x. Literally just read it exactly as you see it. Don't overcomplicate this. P minus 3n minus x is equal to negative RT. So because our focus is to get t by itself, recognize that it is attached to negative r by multiplication. So if I want t alone, I'm going to have to get rid of this negative r by dividing it. We can divide every term all at once by negative r, or I can divide each term individually by negative r. Because I want you to get into the habit of dividing each term individually, I'm going to start doing that moving forward. When we hit Unit 4, we're going to start graphing linear equations, which means we need to have our terms completely separated so that we can identify the slope, so we can identify the y-intercept. Yeah, you love graphing, don't you? I hope you do, and if you don't, you will, I promise. So we really want to be careful and get into that habit now, so that way it's just so much easier when we get to that section, okay? So if I simplify this problem, notice I have p divided by negative r. And we learned throughout this course so far that if our negative is in the denominator, let's either move it up to the numerator or in front of the fraction. So we have negative p over r. Then we have negative 3n divided by negative r. Well, a negative divided by a negative is a positive. So it becomes plus 3n over r. Again, we have negative x divided by negative r. Negative divided by a negative is a positive x over r. And then negative r divided by negative r, well, these cancel, leaving us with 1. So 1 times t is simply t. And your final answer looks something like this. If you wanted to write it as one fraction, it could have been negative p plus 3n plus x all over r is equal to t. That will also be sufficient. For those of you who did not bring the negative up and you left it in the denominator with r, I'm okay with that too. But I will say that I want you to move towards one of these two results, preferably the first one. Okay? Excellent, excellent work. Let's do 2 more and we'll call it a day. G is equal to 1 divided by 5h minus b. Make sure you're moving slow through this because this is not like the ones we've seen already. It's slightly different. And then 9 is q is equal to 4r minus s divided by b. And you're going to solve for h in number 8 and you're going to solve for s in number 9. Good luck. Let's see those answers. For the sake of time, I love all the answers you're putting into the chat, so let me show you what you can do. I'm going to rewrite this. G is equal to 1 over 5h minus b. I have 1, 2, 3 terms. I want to solve for h. Notice we have a fraction here, so we could start off by multiplying every term by the LCD. Why not? So we're going to take each term, place them in parentheses, and we're going to multiply by the LCD, which is 5. This leaves me with 5g is equal to, notice here the 5s are going to cancel. Thank you, Johanna. The 5s cancel, that leaves us with 1h, or simply just h, and then minus 5 times b, which is 5b. We are focused on getting h alone, which means this minus 5b has to go. So we're going to use the opposite operation to bring it to the opposite side. So your answer should be 5g plus 5b is equal to h. Excellent work, everyone. Excellent work. Don't forget about multiplying every term by 5, not just 2 of those terms. Lastly, with number 9, we have q is equal to 4r minus s divided by b. The last thing I said was divided by b, so I'm going to start by multiplying both terms by b. So if I multiply both terms by b, that gives me BQ or QB, totally up to you. So BQ is equal to, notice B and B will cancel. They divide each other out, so that leaves us with 4R minus S. Our focus is to get S alone, so this 4R has to go. This term is positive, so I'm going to subtract it. So if I subtract that term, I'm left with BQ minus 4R is equal to negative s. Just like we learned before, we're going to multiply or divide by a negative 1. So each term has its own sign, and those signs are going to flip. So we go from a positive BQ to a negative BQ, a negative 4R to a positive 4R, and a negative s to a positive s. And there is your final answer. Excellent work, everyone. That was super cool. We finished that section. Practice in Lumen. Hopefully this starts to make a lot of sense. Just keep playing around with it and just keep practicing, and I swear it's going to get so much easier than it has ever before. All right? As always, please email me if you have any questions. And besides that, enjoy the rest of your day, and I'll see you all tomorrow. Bye.